Okay, so I wanted to make a video for this homework question that some of you have trouble with. It says that a satellite dish is shaped like a paraboloid of revolution, and that a signal after reflecting on the dish actually will strike a single point, and that's where the receiver will be located. If the dish is 14 feet across at its opening and 2 feet deep at its center, where should the receiver be placed? So to begin, as soon as you see the word paraboloid, that would mean that we have a satellite dish where if you were to slice a section of this dish with a two-dimensional plane, you would end up with a parabola as a cross-section. So we can actually put this parabola oriented in any of the 4 orientations that we like. Up is usually the easiest for most students, but if you prefer to do a right or a left or a down orientation, that's also okay. For me, I'll just choose to do an upward orientation for now. So something like this is happening. A paraboloid has a parabolic cross-section. Oops, mine's a little ugly here. Let's try to fix that. Sorry about my ugly art skills here. Now technically a parabola would continue going up forever and ever, and left forever and ever, and right forever and ever. But because this is a cross-section of a physical dish, it will have a stopping point. So we will have an opening that stops somewhere. Now, we know some things about this opening. It tells me that the dish is 14 feet across at its opening. So using that information, if it's 14 feet across at its opening, that would mean that if I had this vertex here at 0, 0, if that was at 0, 0 for my vertex, then I now would know these 2 points if this is the entire depth of the parabolic cross-section here. So right here, if the depth is 2 feet deep at its center, this is 2, then I now know these 2 locations, don't I? What do you think they are? If you know the depth is 2, but you know that the total distance across there is 14. Well, yes, you'd be correct, 7 in each direction. So if I put the vertex of the parabola at 0, 0, it would be 7 to the right and 7 to the left, which would be at 7, comma, something, and negative 7, comma, something. The something is the y value there, which if the depth is given to us as 2, we know the answer there is 2 and 2 for the y value. Now, what can be confusing for students is that they might think they have the answer already. The question is, where should the receiver be placed? So if you are under the mistaken assumption, this is a common mistake a lot of students make, that they've given you, by giving you the depth, somehow they've given you the focus here. If that was the focus, they'd have to tell you that. That would have been the answer then. You would have just said 2 feet from the base, right? But they didn't tell us that. They simply gave us that information, the width across and the depth at the center here, to give you 2 locations, an X and a Y. An X and a Y. We really don't know where the receiver should be placed. Should it be placed here, 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 here? We don't know. So in order to find that, we need to recognize that what we're really looking for, where should the receiver be placed? Really, what we're asking you to find is P. We need to find the focus. And the way we get to the focus is P. So we must find P. Sometimes in your homework website it'll say A, but it's the same idea. P was the distance from the vertex to the focus, and also from the vertex to the directrix. So how would we find P? Well, we begin by writing out a model that could describe a parabola. So for our particular situation here, our model for a parabola which opens up the way we oriented it would typically be x getting squared, so x minus h squared. If it's up, it's positive 4p, not negative 4p, times y minus k, where h, k are the coordinates of my vertex. So in this situation, my vertex, the way I oriented it, was at 0, 0, right? So if my vertex is 0, 0, that would mean that my model is even cuter. My model is x minus 0 squared equals 4p times y minus 0. In other words, my model simplifies to just x squared equals 4py. So there is my model, but I don't know what p is. How would I get P? Well, I would need to use information, and that's a pretty common thing in math. We use what is given to help us find the unknown. So since they gave me the information about the depth of the cone being, not the cone, but the parabola being 2 feet here at the center, and the width there being 14 across, or 7 in each case, I will use my points, use the point either 7, 2 or negative 7, 2. Those are x and y values to find, what do you think? To find p, that's right. We're going to do that so that we can find what p equals. Okay, so let's plug in what we know and solve for what we don't know. We go back to our model here. If x is 7 or negative 7, what happens if I square it? Well, it turns out it doesn't matter if I do positive or negative 7. You could do either one, because if you square it, you get 49, don't you? Good job. And then if you input your y value there, which was 2, then the only thing left to find is your p, right? So we plugged in our y value, 2. 2 times 4 is 8. So now we have 8p equals 49. A little bit of basic algebra. We can solve for p. We would get that p equals 49 divided by 8. Well, you could write it that way. You could say 49 divided by 8. You could also get the decimal, 6.125, and that was in feet. So what is that telling me? Well, it's not 2, is it? So sometimes it will turn out that that depth is actually where the focus is. But this time, that's not where the focus should go. It should go 6.125 feet from the base of the dish, right, along its axis of symmetry. It should go up 6.125 feet if I've oriented it up. If I had oriented it to the right instead, it would have gone 6.125 feet from to the right of the vertex. So let's see where that would be. 2, 4, 6, so around here somewhere. This would be the location of where I should put my receiver. The focus here would be at 0, 6.125. This would be my focus. So that is the location of where that receiver should go. Okay, so that is the answer to that question. Now, if you are curious about how you would have continued graphing a normal parabola, not to answer this question, you're done. That is the answer. But if you wanted to understand how you would normally graph this parabola, you would notice that normally it would continue growing, wouldn't it? From left to right forever. And normally you would find the endpoints on the latus rectum, which cuts through your focus. So keep in mind, this is very different than what we call the endpoints. So this is extra fun, in case you're curious about these. Your endpoints on the latus rectum, remember what those are? Those are going to be the points which are 2p, 4p total, so whatever this is in your model. In our case, our model actually became x squared equals 4 copies of 49 over 8, which is really 49 over 2. So if you went into Desmos, this would be the model that you'd be talking about. Once you put in your p, you multiply 49 over 8 by 4, you get 49 over 2. Okay, so this is our model here that represents the situation. Once you have that, this coefficient, 49 over 2, is your total length of the latus rectum. But typically we go 2p in both directions. So the total length of 49 over 2, okay? That total length of 49 over 2, I think I said 49 over 2 several times now. I meant 49 over 4. I'm not sure why I said that. Yeah, 49 over 4 would be what we'd want there. Let's see, 49 over, what am I saying here? Yes, 49 over 2 is the total length, but then if you cut it into 2, divide it into 2, you would end up with 49 over 4. That's what I was trying to think of ahead of time. So 49 over 4 would be the length that you would go in each direction. You could split it up. So this 49 over 2, this was your 4p, okay? Then you divided it in 2. That gives you 2p on each side, 2p on each side. And if you put that in a calculator or do it by hand, it's going to be 6.125 doubled, which should just be 12.250. So you used your 4p, you cut it in half, and you go 2p in both directions. So from the focus, you should be going 2p to the right and 2p to the left. And since 2p in this case is going to be 12.250, the endpoints of the latus rectum would start at 0, 6.125, and go to the right 12.250 and to the left 12.250. So you should be getting negative 12.25, comma 6.125. as well as positive 12.25, comma, 6.125. Okay, again, that was extra information, but I just want you to see the difference. These locations would have been up here somewhere and over here somewhere, okay? So if you were to allow your parabola to continue, those would have been like your endpoints on the latus rectum. But the latus rectum, again, has to go through the focus, and we weren't told where the focus was. Instead, you were asked to find the focus by finding where the receiver should be placed. So being sure that you don't confuse endpoints on the latus rectum with where, in this case, to put the receiver, very different situations since they had not told us where the focus was, but instead had asked you to find it. Well, I hope that was helpful for you. If you have any other questions, please reach out to me. Otherwise, happy practicing, because math is not a spectator sport. I'll see you next time.